Space mining. Just saying the phrase brings to mind the image of a lonely prospector in a scuffed spacesuit, perhaps commanding a rundown spacecraft and shuttling exotic materials between worlds. At least that's the scene we get from science fiction. But in reality, space mining is a potentially serious and lucrative business, and one to which recent asteroid contact missions may have opened the door. But it's unlikely there will be a lonely space prospector doing the digging. Space mining will likely be almost entirely a robotic enterprise. There are obviously many challenges to mining in space, but Simon Drake, CEO of the Lunar Resources Registry, says it's also inevitable.
It's the next logical, historical, and industrial step for humanity. And it's not a case of why, it's a case of when. And, we live in an interesting time, a time of innovation, of technology. So space mining is, to many people, it's a question, why not?
So far, only a few robotic spacecraft have been up close and personal with an asteroid. NASA's Dawn spacecraft was launched in 2007 to explore the asteroid Vesta. Dawn spent more than a year orbiting Vesta before leaving to explore the dwarf planet Ceres. President Barack Obama made asteroid exploration a primary focus of NASA during his administration, proposing missions that would capture an asteroid and tow it back to Earth, and even a manned asteroid exploration mission. Those fell by the wayside after the election of President Trump, who refocused the agency on a manned space program, returning to the Moon, and going to Mars. But NASA and other space agencies haven't lost their interest in asteroids. Japan's Hayabusa 2 mission returned an asteroid sample from Asteroid Ryugu in December of last year, and NASA's OSIRIS-REx spacecraft is on its way back to Earth after collecting samples from Asteroid Bennu. That's essentially what you could call asteroid prospecting and exploration, the first two stages in the mining and mineral recovery process, according to Boss magazine. And such prospecting is not limited to asteroids. One of the missions of NASA's Perseverance rover is to collect Martian soil samples that will be returned robotically to Earth, and the agency's Ingenuity helicopter is actively scouting for interesting areas to prospect.
When you look at these steps of technology, even though they're quite minuscule compared to the amount of drilling that's been happening on Earth for thousands of years, the small amount of drilling that has happened on Moon, asteroids, Mars, if you continue that and scale it massively up, then you can start building a better picture of where the resources are and how you extract them.
While there is no doubt that the human race is going to develop an industry to exploit the resources available in space, what is not as clear is what we will find.
So what we want to find is kind of based on what we expect to find, which we think we can profit from in the moment. So if you go back to a traditional old world, new world exploration, mining, it was all about Europe, opening up silver mines from, in the New World, the Americas, and that silver trade boosted the European economies and several empires and really changed history. Some would argue that, the Renaissance was thanks to this kind of wealth coming over from the New World. But I think with space mining, this mentality of, first come the metals, which I always, like the metals anyway. It might actually be something different. In space mining, it might be all about extracting propulsion from asteroids, because if you look at historical precedents, to discover the New World, ships had to sail and they had required wind. So if you look at space mining, how we achieve these great distances is going to be dependent on how we extract propulsion from resources that we can easily tap into on our way to where we want to get to.
Distance is obviously one of the main hurdles that needs to be overcome for mining asteroids, but perhaps a more immediate challenge is to convince the public that it's something we should be working on now.
To me, the biggest challenge is in some ways public sentiment, that we should be looking at space mining now rather than assuming a following on generation will want to do it, because it starts with us, and we live in a grand time where we have technology, we have a great way of rearranging capital to interesting projects, we have a lot of brainy people more than ever. So I think the biggest thing for space mining is that kind of persuasion of the public, which then turns into persuasion of governments to focus more in that direction.
In December 2020, NASA announced that it had selected 4 companies to collect lunar regolith that the agency would pay for. Lunar Outpost of Golden, Colorado, Mast and Space Systems of Mojave, California, iSpace Europe of Luxembourg, and iSpace Japan of Tokyo were chosen for the program, and the total value of the 4 contracts was set at $25,001. According to NASA, space resources will play a key role in its Artemis program and future space exploration. The ability to extract and use extraterrestrial resources will ensure Artemis operations can be conducted safely and sustainably in support of establishing human lunar exploration. Moreover, in situ resource utilization, or ISRU, will play a vital role in a future human mission to Mars. Like many other operations, ISRU activities will be tested and developed on the Moon, building the required knowledge to implement new capabilities that will be necessary to overcome the challenges of a human mission to Mars. Companies will collect a small amount of lunar regolith from any location on the Moon and provide imagery to NASA of the collection and the collected material, along with data that identifies the collection location. Subsequent to receiving such imagery and data, an in-place transfer of ownership of the lunar regolith to NASA will take place. After ownership transfer, the collected material becomes the sole property of NASA for the agency's use under the Artemis program. This will set the stage for the industrial use of regolith on the Moon and eventual habitation.
To use these resources for a habitat is core to a habitat survival. On the Moon, the biggest resource that is required will be oxygen and water. So you can see the first steps of space agency funded research to try and get water out of the Moon, whether it's going to Shackleton Crater and trying to find what's down there, or using a lot of energy to try and get oxygen out of regolith.
Drake's company, Lunar Resources Registry, is in the process of identifying areas on the Moon where resources may be available, with a goal of coordinating the extraction of mineral resources on the Moon.
We've detailed how to create a commercial registration for terrestrial mining companies or energy companies that want to branch out and start looking at the Moon as a next investment opportunity, and also as a potential resource for cislunar operations. So as a registry, we focus on being a registry and also look at a lot of the analysis that goes into how resources are detected. And it's an exciting time to be building such a business, because all great endeavors, they start off with a bit of chaos, and then organizations come and apply some order to it. And through that order, the next level of entrepreneurs can build on that base and start building operations.
There are many legal questions to be answered as the era of space mining begins. The United Nations Outer Space Treaty, that went into force in 1967, states clearly that outer space is not subject to national appropriation by claim of sovereignty, by means of use or occupation, or by any other means. Many have interpreted the treaty as precluding the claiming of mineral rights on extraterrestrial bodies. However, the U.S. Commercial Space Launch Competitiveness Act, which became law in 2015, states in Title IV, a United States citizen engaged in commercial recovery of an asteroid resource or a space resource under this chapter shall be entitled to any asteroid resource or space resource obtained, including to possess, own, transport, use, and sell the asteroid resource or space resource obtained in accordance with applicable law, including the international obligations of the United States. It goes on to say that it was the sense of the Congress that, by enactment of this act, the United States does not thereby assert sovereignty or sovereign or exclusive rights or jurisdiction over or the ownership of any celestial body. So, it's reasonable to assert that the era of space mining has arrived, though commercial viability is still years, if not decades, in the future. Space mining in the nearer term may be limited to the extraction of resources for building infrastructure on the moon, as well as other vital materials such as water that can be used both for human consumption as well as the creation of fuel for spacecraft. But inevitably, just as Europeans crossed vast oceans in the search for resources from the New World, so will humanity cross the vastness of space in search of the materials we need to expand beyond our current horizons. For Xterra, the Journal of Space Commerce, I'm Tom Patton.